everyone. So today we are going to work on this planet gravity system. So this is the same map where we worked on our planet gravity character system as well. So if I simulate this, here you can see these objects falling towards this surface of the planet. See, so even if the object is in the downside, it falls towards the planet surface, and this is resting in this platform because this platform is parallel to the planet surface underneath the platform. But if I move the platform, it continues to fall. Right, so let me show you again and simulate. Now see, okay, so that's the demonstration. And also, if I play, here is my character, and my character can walk around the planet. So this is not something that we are going to work on today because we have already worked on this system previously. So yeah, let's see how to implement these physics objects today. So this is the same project I worked on, this planet gravity system, where we can walk around this planet, this spherical planet, and also fly to other planets as well. So yeah, so now I want to implement some physics objects that if I drop it in this world, it should be falling towards the planet. Even if I drop it maybe somewhere here, it should fall towards the surface of this planet instead of falling it down along the z-axis. Alright, so here let's add a new blueprint class from the actor P6 object. Right, now here first I'll add, let's add a sphere component. Let's make that the root of the object, and I'll enable physics, simulate physics. Let me just simply put it here, and if I play, wait, I can't see that if I play, so let's simulate. If I simulate, you see that object falls down like in the normal situation. So like it's considering the vertical gravity. So now if I disable physics, disable gravity, then it will not fall down, but it will not move either. So yeah, now in order to implement planet gravity, let's add a variable planet. Let's make it public, and I'll change this type to actor object reference, and here I'll set this planet as the planet reference. Now in the event graph, first we need to check if we have a valid planet. So let's convert this to validated get. If we have a valid planet, then we can get the location of the planet, and also we can get back the location of this object itself, and then we can calculate the direction from this object to the planet. So this would be our gravity direction. Let's call it gravity. Or maybe gravity, just gravity. Right, and we can set it here. So actually then we can add force to the sphere. So we only have this gravity direction here. Oh, let's change this gravity direction here, because if I name it as gravity, then it doesn't make sense to multiply it with another float variable. So gravity direction, let's multiply this with a float. Let's say 500. So actually we can change this if we want, depending on the gravity intensity of the planet, but let's test with 500. Oh no, why don't we update this gravity power? Okay, and I think I have to enable this acceleration change, yeah, otherwise it doesn't work. Okay, now here we have our object. So if I simulate, it falls down like this and bounces, but it doesn't really stop, it keeps moving and the movement speed increases. The reason is actually this is not a perfect sphere, so because of that, if we consider, so because of that, the gravity direction and the normal of this surface doesn't always match, so that's why it always getting some force to move. See, so this will eventually be fast as the time goes. So we need to fix that. Wait, let me first increase this linear damping a bit and see that solves the problem, but I don't think it will completely solve it. Yeah, it doesn't. No, it's not solving the problem. Right, okay, so then let's implement a method. Right. Yeah, let's implement a method to detect if the sphere is hitting the same position. That means if sphere is somewhat in a stationary mode. So if that is the case, let's stop applying this gravity. So to detect hits, let's select this sphere and that's the physics. Here, simulation generate hit events, and let's get a hit event. Right, then when a hit happens, we can break this and access normal. By comparing this normal with the gravity vector, with the gravity direction, we can check if this is like if the object is falling on the floor or in an angled surface. So if it is falling on the floor, then that means there might be a way to stabilize it. So yeah, to compare this with the gravity vector, let me multiply this with a -1 so that it becomes the same direction as the gravity. If this is a surface hit on this planet surface or on some object that is parallel to the planet surface. Let's compare this with the gravity vector by checking the distance. So if these two are identical, then the value becomes 0. But since this is not a perfect sphere, we will always have some value here. But if this value is less than, let's say 0.1, then let's treat it as the planet surface or a surface that is parallel to the planet surface. Let's add the branch. Let's hide. Oh, we can't hide unconnected. Okay. Now to check this, let's just add a print and print this value. See, a very small value, and we continue to get hits as the object seems to be stationary also, right? And now I don't need the print. Let's add another variable. Let's call it hit count, and this type should be an integer. So if the hit count exceeds a certain value, let's say 100, we should stop applying the gravity force. So that means the object is stabilized on the floor. That's what it means, right? So here, get the hit count and increment. If we get a different hit, then we should reset the hit count. So set hit count back to 0. And if the hit count is larger than 100, let's stop applying the gravity force. But to do that, to control that, let's add another variable. Let's call it resting. So physics resting mode. Boolean. By default, resting is false. That means we are applying the gravity force. Here let's set resting to true. Well, if I connect this, that will make it true. Or if you want to make it a bit clearer, let's add a branch. If yes, let's make it true. Okay, now here set a branch. Right. And do the rest only if the object is not resting. Right, now let's see. Okay, now it doesn't continue to move after hitting the floor. Great. But we may have a problem. What if, let me add another cube here. Why can't I move it? Oh. Does it hit? Yeah. Right. Oh, it doesn't stabilize on there because the object is, this surface is not perpendicular, not parallel to the planet surface. Right, so let's move this both to 0, 0 location. Where is it? Where did it go? Oh, here. Well, actually not 0, 0, we should go move it to this location. Same location, same XY location as the green planet. So now if I drop it, it stays like this. Okay, but the problem is if I remove this, this doesn't fall down. Looks like two cats are trying to kill each other outside. Okay, also maybe let me move this to a side because this kind of makes us forget about that we are not really implementing planet gravity. Right, now better. Okay, so how to make the object fall again if I remove this platform? So for that, instead of directly setting the rest in here, let's add a custom event. Let's call it rest. And then first here I'll add a do once node because in case this is called more than once, and here let's set a delay of, let's say, something like 0.4 seconds, no, first I'll set rest to true, then add a 0.4 second delay. Then let's do a line trace by channel. So the start location should be actor location, and end location should be planet location. So here I don't think we will we have to have a validated gate. Maybe not, because if we don't have a planet we wouldn't be here. But yeah, in case of any possibility, it would be better to have a validated gate here, but for now let's just forget about that. To test this, get actor location, right? Now that's the end, and visibility channel should be fine. Here, if we get a hit, if we don't get a hit, then definitely we should stop resting. So set resting to false and reset this. Like this. Okay, and if we do get a hit, then we need to check what we have to check. Couple of things. First thing is we have to check this normal and see if it is aligning with the gravity vector. So we can use the same calculation we did here. So we can add this to a macro. Is gravity aligned? Yeah. Well. Okay. If yes, also we may have to check the distance as well, the line trace distance, and it should match the distance we get here. So let's promote this to a variable. Let's call it hit dist. Okay, because the reason I'm using that is if I just move down that platform, we should also be able to detect that as well. So here we have the distance, and this does not have to be 100% equal, so let's use nearly equal. This one and the hit distance. So within a range of what? Maybe let's try this like 10. We can change it, of course. branch, this one and this one. Both of these conditions should be true in order to remain resting. Otherwise, we should stop resting. That means here. If this is true, that means we can remain resting. So node and another reroute node and connect. Oh wait, wrong. That's not the way I imagined it. Right. Send another reroute node here. Alright, shall we check? Okay, I think it stopped applying the force. Now we can check it here. Oh wait, we haven't still called rest. Yeah, now it's in the resting mode, and let's try moving this, and it falls down. Great. So it works as intended. Oh wait, why is this keep jumping up and down? What if I move this afterward? Set resting to true after this step. Alright, now it works. Okay. So, yeah, that works as intended. Shall we put some more objects? Oh, we are still simulating. Let me add a few more objects. And test. Okay, I think they are working as we expected. Yeah. Great. One more thing. Let me speed up the camera. Let's add one with this platform. below. Oh, it didn't hit. Let me make this a bit longer. Alright, it works. Great. So let's try to match this 180 to the Earth's gravity, the default gravity scale we have. And what if we make these spheres a bit larger so we can easily see them? Alright, one more thing. Let's make one of them instead of a sphere, cube. Right, still works. Great. This small movement is due to we don't have any angular anything. Shall we apply some? Right. Okay, so I think we can stop this episode right here. Great. So thanks for watching. As always, project files will be available for the download in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon Club. See you in another episode. Goodbye.